Good afternoon. Welcome to session 5 of Unit 4 Digital to Analog Converter and Analog to Digital Converter. In the previous session, that is in session 4, we were discussed about specifications of digital to analog converter. In session 5, I am going to discuss about simple problems on digital to analog converter. In this section, we are going to solve some simple problems related to digital to analog converter, and then we are going to discuss about some of DAC ICs and their features. Problem number 1. A 10-bit digital to analog converter has a step size of 10 millivolt. Determine the full-scale output voltage and the percentage resolution. In this problem, they are given step size of 10 millivolt and they specify the DAC is 10-bit DAC. They are specifying as DAC is 10-bit DAC and they are given step size of 10 millivolt. In this problem, we have to find out full scale output voltage and percentage resolution. Before going to solve this problem, we should know the relationship between full scale output voltage, step size and percentage resolution. So in digital to analog converter, full scale output voltage can be written as total number of steps in the DAC output waveform is multiplied by step size. We know DAC output waveform is a staircase waveform. ಹೌದಲ್ವಾ ನಮಗೆ ಏನಂತ ಗೊತ್ತಿದೆ DAC output waveform staircase waveform ಅಂತ ಅನ್ಕೊಂಡಿದ್ದೀವಿ. ಸೊ staircase output waveform ಅಂತ ಅಂದ್ರೆ ಹೇಗಿರುತ್ತೆ? Output waveform ಇದರ staircase form ಅಲ್ಲಿ ಇರುತ್ತೆ. So this is the output of the DAC. So this is the step size, single step size. This. So total number of steps is multiplied by step size is nothing but full scale output voltage. So this is the full scale output voltage. This is full scale output voltage. So this is the full scale output voltage here. Yes. So this is the full scale output voltage. So full scale output voltage can be achieved by multiplying the total number of steps present in the output wave and the step size. And total number of steps is multiplied by step size. Step size is 10 millivolt. So to find out full scale output voltage, first we should know about how many steps or how many intervals are present in this DAC. So the DAC is 10-bit DAC. So total number of steps present in the DAC is 2 to the power of 10 minus 1. In general, to find out the total number of steps present in the output, what is the formula we are using? The formula is 2 to the power of n minus 1 for n-bit DAC. So in this problem, they are specifying DAC is 10-bit. So total number of steps can be calculated as 2 to the power of 10 minus 1 is equal to 1023 steps. 2 to the power of 10 means 1024. So minus 1 means 1023 steps. So there are 1023 steps in 10-bit DAC of step size 10 millivolt. So size of the each step is 10 millivolt. So the full scale output voltage is equal to total number of steps is multiplied by step size. Now we can substitute total number of steps as 1023 and it is multiplied by step size of 10 millivolt. Totally we get 10.23 volt as a full scale output voltage. So for 10-bit DAC with a step size of 10 millivolt, what is the full scale output voltage? The full scale output voltage we get here is 10.23 volt. Next, what we have to find out? We have to find out percentage resolution. So, what is the formula for percentage resolution? For the percentage resolution, the formula is step size divided by full scale output voltage. Step size resolution is equal to step size divided by full scale output voltage is multiplied by 100. We know what is step size. Step size is 10 millivolt and full scale output voltage is 10.23. Substitute these values in this formula and we get a percentage resolution of 0.1%. So in this way we can solve the problem. Next problem. A 6-bit DAC has a step size of 50 millivolt. Determine full scale output voltage and percentage resolution. So in this problem, the DAC is 6-bit DAC and the DAC has a step size of 50 millivolt and we should find out full scale output voltage and the percentage resolution. We know the formula for full scale output voltage, that is full scale output voltage is equal to total number of steps is multiplied by step size. So first we have to find out the total number of steps for 6-bit DAC. For 6-bit DAC, how we can find out the total number of steps, that is 2 to the power of 6 minus 1. So total number of steps is equal to 2 power n minus 1. Here n is 6 because the DAC is 6-bit in size. So 2 to the power of 6 minus 1 is equal to 63. So DAC has total 63 steps. So next, we can easily find out the full scale output voltage. So full scale output voltage is equal to total number of steps is multiplied by step size. So total number of steps is nothing but 63 and step size is of 50 millivolt. By multiplying these two values, we get 3.15 volt has full scale output voltage for the DAC. So next is the percentage resolution. So percentage resolution is equal to step size divided by full scale output voltage. So step size is 50 millivolt and we get 3.15 volt as full scale output voltage. So percentage resolution is nothing but 50 millivolt divided by 3.15 volt is multiplied by 100, that is 1.58%. Shall we move on to the next problem? Problem number 3. For the R by 2R ladder DAC, find full scale output voltage if RF is equal to 2 kilo ohm and R is equal to 1 kilo ohm. Find out voltage when binary input is 101100. Assume VR is equal to 5 volt. ಏನು ಹೇಳ್ತಿದ್ದಾರೆ? In this problem, we have to find out full scale output voltage. What is full scale output voltage? This is the output voltage. Full scale output voltage is a output voltage that the DAC can produce voltage when all its binary inputs or digital inputs are at logic high. ಅಂದ್ರೆ ಏನು ಫುಲ್ ಸ್ಕೇಲ್ ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜ್ ಅಂತ ಅಂದ್ರೆ ನನಗೆ DAC ಏನ್ ಮಾಡ್ತದೆ, DAC has to produce the output voltage when its digital inputs are at logic high. All DAC digital inputs are at logic high. ಎಲ್ಲ ಇನ್ಪುಟ್ಸ್ ಕೂಡ ಏನಾಗಿರ್ಬೇಕು, DAC ಅಲ್ಲಿ ಲಾಜಿಕ್ ಹೈ ಆಗಿರ್ಬೇಕು. ಅವಾಗ DAC ಏನ್ ವೋಲ್ಟೇಜ್ ಅಂತ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುತ್ತೋ ದಟ್ ವೋಲ್ಟೇಜ್ ಇಸ್ ಕಾಲ್ಡ್ ಫುಲ್ ಸ್ಕೇಲ್ ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜ್ ಅಂತ ಹೇಳ್ತೀವಿ ಅಂತ. ಸೊ to find out the full scale output voltage in R2 or ladder type DAC, we should use the formula. ಯಾವ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಬೇಕು? Vout is equal to V reference into feedback resistor RF divided by R resistor R is multiplied by B1 by 2, B2 by 4 plus B3 by 8 plus B4 by 16 ಅಂತ ಯೂಸ್ ಮಾಡಿದ್ವಲ್ಲ ಫಾರ್ಮುಲಾ while designing the R by 2R ladder. Thereby we get the output expression for Vout. ಹೌದಲ್ವಾ? Vout ಗೆ output expression ನಾವು ಡಿಸೈನ್ ಮಾಡಿದ್ವಿ, ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ವಿ ಅಲ್ವಾ? 4-bit R 2R ladder type DAC. ಆ ladder DAC ಗೆ ಏನು ರಿಲೇಶನ್ಶಿಪ್, ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜ್ ರಿಲೇಶನ್ಶಿಪ್ ಸಿಕ್ಕಿತ್ತೋ the same formula we have to use here. But in this problem ಏನಾಗಿದೆ, ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೋಬೇಕಾಗಿರೋದು, ವಾಟ್ ಇಸ್ ದ ಪಾಯಿಂಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಅಬ್ಸರ್ವ್ ಇನ್ ದಿಸ್ ಪ್ರಾಬ್ಲಮ್ ಈಸ್ the digital inputs applied for this DAC is 6 bit in wide. So digital inputs ಎಷ್ಟು ಬಿಟ್ಸ್ ಇದಾವೆ? 6 ಬಿಟ್ಸ್ ಇದಾವೆ. ಸೊ ಹಾಗಿದ್ಮೇಲೆ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡಬೇಕಿದ್ರೆ 6 ಬಿಟ್ಸ್ ಗೆ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಅಂಡ್ ಒನ್ ಮೋರ್ ಥಿಂಗ್, they are given the value of RF and R1. ಮತ್ತೆ ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ? Assume VR means reference voltage has 5 volt. 5 volt ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೋಬೇಕು ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ಸೊ ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ಏನ್ ಮಾಡಬೇಕು? ವಿ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಔಟ್ ದ ಫುಲ್ ಸ್ಕೇಲ್ ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜ್. ಇಲ್ಲಿ ಫುಲ್ ಸ್ಕೇಲ್ ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜ್ ನ ಫಸ್ಟ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೋಬೇಕು. ಸೊ for that we have to use the formula. ಯಾವ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡ್ಕೋಬೇಕಪ್ಪ ಅಂದ್ರೆ Vout is equal to VR into RF divided by R, B1 by 2 plus B2 by 4 plus B3 by 8 plus B4 by 16, B5 by 32 plus B6 by 64. Because this DAC is 6 bit. The DAC has 6 digital inputs. 6 bits of digital inputs ಇದೆ ಇಲ್ಲಿ ಅಂತ. ಸೊ ಫುಲ್ ಸ್ಕೇಲ್ ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜ್ ಅಂದ್ರೆ ಯಾವಾಗ ನಮ್ಗೆ ಫುಲ್ ಸ್ಕೇಲ್ ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜ್ ಸಿಗುತ್ತೆ? ವಿ ಗೆಟ್ ಫುಲ್ ಸ್ಕೇಲ್ ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜ್ when all binary inputs or digital inputs are at logic high. That is, all 6 bits are at logic high. So we have to consider B1, B2, B3, B4, B5, B6 as logic 1. So by substituting the value of VR as 5 volt, for RF you have to substitute 2 kilo ohm, and R1 we have to substitute 1 kilo ohm. So B1, B2, B3, B4, B5, B6 are at logic high for full scale output voltage. So Vout, here Vout is B full scale output voltage is nothing but 9.843. And they told one more point to find out, that is find out output voltage when binary input is 101100. ಅಂತ ಅಂದ್ರೆ ಏನು? ನಾನಿಲ್ಲಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೋಬೇಕು ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜು ಫಾರ್ ದ ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ದ ಇನ್ಪುಟ್ ಬಿಟ್ಸ್ ಬೈನರಿ ಡಿಜಿಟಲ್ ಇನ್ಪುಟ್ಸ್ 101100ಗೆ ಅಂತ. ದ ಸೇಮ್ ಫಾರ್ಮುಲಾ ವಿ ಹ್ಯಾವ್ ಟು ಯೂಸ್ ಟು ಫೈಂಡ್ ಔಟ್ ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜ್ ಫಾರ್ ದಿಸ್ digital input, but in place of B2 and B5 and B6 we have to put logic 0. So output voltage for the binary input 101100. I told for B2 we have to put 0 and B5 we have to put 0 and B6 for B6 we have to put 0 and remaining B1, B3 and B4 bits are at logic high. So the output voltage for this 101100 input is 6.87 volt. Next, DAC ICs. So here I list some of the DAC ICs First one is DAC0808. This is 8-bit DAC. DAC08, it is also 8-bit monolithic digital to analog converter. DAC0832 is 8-bit parallel input digital to analog converter. DAC1408 is 8-bit R to R ladder type digital to analog converter. So let's observe the pinout diagram of each DAC IC and ಅದ್ರದ್ದು features ಏನಿದೆ ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಣ. Let's understand the pinout diagram and features of DAC ICs one by one. The first IC is DAC0808. The DAC0808 is a 16-pin IC. In this IC, the pin number 1 is not connected. Pin number 2 is ground. Pin number 3 is negative voltage, negative power supply. This pin number 3 is negative power supply VEE. This negative power supply voltage is used for analog ground. Analog voltage, output voltage ಬರುತ್ತಲ್ಲ ನಮಗೆ ಅದಕ್ಕೆ ನಮಗೆ ಈ ನೆಗೆಟಿವ್ ಪವರ್ ಸಪ್ಲೈ ಬೇಕಿರುತ್ತೆ. Next pin number 4 is output current. In this IC, the analog output is available in the form of current. So, ನನಗೆ voltage output ಸಿಗಲ್ಲ. ನನಗೆ ಎಂತ ಫಾರ್ಮಲ್ಲಿ ಸಿಗುತ್ತೆ analog output? The analog output is in the form of current. This current can be converted into voltage by connecting load resistor at this pin. Across the load resistor, we can get the analog output voltage. This A1, A2, A3, A4, A5, A6, A7 and A8. These are 8 digital inputs. These digital inputs are parallel digital inputs. Here A1 is the MSB and A8 is the LSB. Pin number 13 is VCC. Through this pin we can provide plus 5 volt power supply for the IC. Pin number 15 and pin number 14 are for providing negative reference voltage and positive reference voltage respectively. ಈ 14 ಮತ್ತೆ 15 ಇಂದ ನಿಮಗೆ ಪಾಸಿಟಿವ್ ರೆಫರೆನ್ಸ್ ವೋಲ್ಟೇಜ್ ಮತ್ತೆ ನೆಗೆಟಿವ್ ರೆಫರೆನ್ಸ್ ವೋಲ್ಟೇಜ್ ಸಿಗ್ತಾ ಇರುತ್ತೆ. Pin number 16 is compensation. Compensation pin means here compensation capacitor is connected. So this is the compensation capacitor pin. So what are the features of DAC IC0808? This DAC 0808 is a 8-bit parallel digital data input. So 8-bit parallel digital data input. In this IC there are 8-bit parallel digital data inputs. The settling time for this IC is 150 nanoseconds and relative accuracy is at plus or minus 0.19%. Full scale current is matched with plus or minus 1 LSB. Non-inverting digital inputs are TTL and CMOS compatible. ಏನಂದ್ರೆ what is the meaning of TTL and CMOS compatible ಅಂತಂದ್ರೆ the digital inputs A1 through A8 ಏನ್ pins ಇದೆಯೋ the all digital input pins are compatible with the TTL family of inputs and CMOS family of inputs ಅಂತ. ಅಂದ್ರೆ for TTL family of input gates and CMOS family of gates, the voltage rating, input and output voltage rating is different. ಸೊ ಅದಕ್ಕೆ ಇಲ್ಲಿರುವಂತ ಐಸಿನ ಏನು ಪ್ರೊವೈಡ್ ಮಾಡಿದ್ದಾರೆ ಐಸಿನಲ್ಲಿ ಏನು ಪಿನ್ಸ್ ಇದಾವೋ ಆಲ್ ದ ಪಿನ್ಸ್ ಆರ್ ಕಂಪ್ಯಾಟಿಬಲ್ ಫಾರ್ ಬೋತ್ TTL family of input logic inputs and CMOS family of logic inputs and outputs ಅಂತ. High speed multiplying input slew rate. Slew rate is 8 milliampere per microsecond. Power supply we are going to connect to this IC is the range of plus or minus 4.5 volt to plus or minus 18 volt. The power consumption of this DAC IC is 33 milliwatt at plus or minus 5 volt. Plus or minus 5 volt supply kodre the power consumed by this IC is 33 milliwatt. Maximum power dissipation is 1000 milliwatts. Operating temperature range 0 degrees Celsius to plus 75 degrees Celsius. So, this temperature range, ಯಾವ temperature alladru DAC AC can operate. So, these are the features of IC0808. Let's go for DAC IC08. DAC IC08 is also 16 pin IC. In this IC, the pin VLC is not connected. I out bar. This is the inverted current output pin. V minus is negative power supply pin. I out is current output. So in this IC you can observe there are two pins for the output. Pin number 4. At pin number 4 we are getting current output. At pin number 2 we can get inverted output of I out. At pin number 4 we can get actual current output. Analog output it is available at the pin number 4 of 5C08. So, a current output barthirutto, for that output, this IC also provides inverted output at pin number 2. B1, B2, B3, B4, B5, B6, B7, B8 are 8 digital inputs. B1 is MSB and B8 is LSB. V plus means this is positive power supply. V reference plus and V reference minus, these two pins are used to provide positive reference voltage and negative reference voltage respectively. comp. This pin is used for providing the compensation capacitor. So let's go for features. Settling output current. Settling time for this IC is 85 nanosecond. Full scale current permitted to plus or minus 1 LSB. Direct interface to CMOS, TTL, ECL, HTL and PMOS. And DAC IC08 is compatible with TTL family of input output, CMOS family of input output, ECL family of input output, HTL family of input output and PMOS family. Non-linearity to 0.1% maximum over temperature range. I output impedance and combined lens minus 10 O2 plus 18 volt. Complementary current output. So ಇಲ್ಲಿ ನನಗೆ output ಯಾವ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಸಿಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ನನಗೆ this IC has both actual I out current output, with that the IC has complementary current or inverted current output. Wide range multiplying capability 1 megahertz bandwidth. Wide power supply range is plus or minus 4.5 volt to plus or minus 18 volt. Low power consumption. The consumption of the power is 33 milliwatt at plus or minus 5 volt. And this IC is low cost. So these are the features of DAC IC08. Next one is DAC IC0832. DAC IC0832 is 20 pin IC. In this IC, pin number 1 is chip select. This is the active low pin. This pin is used for selecting the DAC 0832 or enabling the DAC chip. The right bar is also a active low pin. This pin is used to write the actual digital inputs to be converted. ನನಗೆ digital input na convert ಮಾಡಬೇಕು ಅಂತ ಅನ್ಕೊಂಡಿರ್ತೀವೋ, that input has to be placed on the digital inputs provided on this pin. Before that, we have to enable this write bar. Next, pin number 3 is ground. This one, DI3, DI2, DI1, DI0, DI4, DI5, DI6 and DI7. These are the digital inputs, 8 digital inputs. DI0 is the LSB and DI7 is the MSB. Pin number 9 is used for connecting the feedback resistor. So feedback resistor is connected to this pin number 9 RFB. Pin number 10 is the ground. Pin number 11. In this IC there are two current outputs. One is I out 1 and I out 2. Pin number 11 and pin number 12 respectively. Pin number 17 is transfer control signal pin. This is also a active low pin. Pin number 18 is write bar 2. So write bar 2, write enable 2. This is also active low. Next, pin number 19 is input latch enable. This input latch enable is used to latch the input and output. Pin number 20 is VCC. Having what are the features of DAC IC 0832? This 0832 DAC is 8-bit parallel digital data input. That means the DAC contains 8 different parallel digital data inputs, operates on single power supply. So only one power supply. We require only one power supply. Direct interface to all popular microprocessor. So we can directly interface this IC0832 to any popular microprocessor. Microprocessor ke direct age interface ಮಾಡ್ಕೋಬಹುದು. Digital inputs are TTL and CMOS compatible. All the digital inputs are TTL and CMOS compatible. Works with plus or minus 10 volt of reference voltages. Easy interchange and compatible with the 12-bit DAC 1230 series. So, this 8-bit DAC alva, this DAC is also interchange with are compatible with 12-bit DAC 1230 series jothe easyagi we can interchange this DAC IC0832 with 12-bit DAC 1230. Power supply voltage range is plus 5 to plus 15 volt. Power consumption of this IC is 20 milliwatt. Maximum power dissipation is 500 milliwatt. Operating temperature range is 0 degrees Celsius to 75 degrees Celsius and it has maximum ESD protection up to 800 ohm. So these are the features of DAC IC 0832. The next one is DAC IC 1408. This is also a 16-pin IC. In this IC, A1, A2, A3, A4, A5, A6, A7, A8 are the digital inputs. A1 is the MSB and A8 is the LSB. This 13 pin number 13 is used for providing the VCC to the chip. And pin number 14 and pin number 16, these two pins are used for providing reference voltage, positive reference voltage and negative reference voltage respectively. V is the negative power supply pin and pin number 2 is the ground and 16 is pin is used for connecting compensation capacitor. So this is the pin for compensation capacitor pin. Features. Settling time of this IC is 70 nanosecond. This IC is also 8-bit digital to analog converter. The accuracy is plus or minus 0.19%. Non-inverting digital inputs are TTL and CMOS compatible. Here, the inputs of IC 1408 is non-inverting digital inputs. High speed multiplying rate 4 milliampere per microseconds. Output voltage swing plus 5 volt to minus 5 volt. Standard supply voltage plus 5 volt and minus 5 volt to minus 15 volt. So power supply range ನನಗೆ ಈ ರೇಂಜ್ 5 ವೋಲ್ಟ್ ಇಂದ minus 5 ವೋಲ್ಟ್ minus 15 ವೋಲ್ಟ್ minus 5 ವೋಲ್ಟ್ minus 15 ವೋಲ್ಟ್ ನಾನು ಪ್ರೊವೈಡ್ ಮಾಡಬಹುದು. So these are the different DAC ICs available in the market. The ICs are DAC IC 0808, DAC IC 08, DAC IC 0832, DAC IC 1408. So now we reach the end of this session. Thank you.